Okay, good afternoon everyone and welcome to another ATRA webinar. Today's webinar is sponsored by Seal Aftermarket Products. We want to thank them for sponsoring all our webinars, making them free to everyone as far as members and non-members. I want to play for you a short video for you on the Seal Aftermarket Products.
Seal Aftermarket Products engineers and manufactures Toledo Transkit with all the extra components you need to get the job done right. Toledo Transkit includes aftermarket fixes engineered by expert rebuilding technicians with enhanced component materials and key original equipment, gaskets and seals. When servicing Honda and ATRA transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda ATRA kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, I've always appreciated using their kits, having all those little extras in there, so I didn't have to dig through some old kit boxes to find the stuff that I needed. If you have any questions or comments, please send your emails to webinars@atra.com. If you have any questions during the webinar, please feel free to text them to me, and I will try to answer them the best that I can. Okay, today's webinar we're going to be covering the introduction to the ZF8HP. Later on in the year we will cover the internal components for the same transmission. As you can see here, this transmission comes in all shapes and sizes. It can be all-wheel drive, four-wheel drive, or just front-wheel drive. So when these come into your shop, they can be set up for almost any type of vehicle out there that you may run into. Now, ZF refers to this transmission as the 8HP45. There are other versions and torque ratings available. There's the HP30, the 70, and the 90. These different versions will be used in several different vehicles, as you see listed here, since about 2010. Now, in 2012, Chrysler 300 and Dodge Charger started using them, and they referred to this transmission as the 845RE. Now, even though this is an 8-speed transmission, it has fewer moving parts than the 6-speed. There's only 2 multi-disc brakes and 3 driving clutches. Multi-disc brakes are A and B, and the turning clutches are C, D, and E. Now, whenever you're in a particular gear, whether it's first, second, eighth, there's going to be only 5 clutches elements that are open. Only 2 out of the 5 will be open. That reduces drag on the transmission. So the fewer elements that are applied, the less rotating mass rolling around in the transmission, less drag. This helps reduce friction loss and also helps the fuel economy and also acceleration. So you have less parts dragging back on the transmission. You can get a better acceleration out of it. The only other transmission I can think of that compares to this is the Lexus AA80E. That's also an 8-speed. They have 4 gear sets just like this transmission, but they have 7 multi-disc clutch packs. Let's talk a little bit about some of the features you'll find here. They've enhanced the planetary gear meshing to help reduce the noise in the transmission. There's an offset chain-driven variable displacement pump, so the pump's not right there in the center of the back of the bell housing. It's actually offset to off to the side a little bit lower than the center. There's also engine stop-start feature, and you may not find this on some of the earlier Chryslers, but you'll start seeing it on some of the later models. It's hybrid capable, and they have a non-sequential shifting, and we're going to talk a little bit about that as we go through the webinar. You can see the torque capacity here. Also, when you're in the sport mode and you're using either the shifter on the console to manually shift the transmission, the actual shift time is down to 200 milliseconds. There's also a neutral idle control. This basically slips the B clutch, reduces load on the vehicle, and prevents creeping. So that also saves fuel economy on the vehicle also. You have several different adaptive strategies: high temperature, warm-up, cruise control, winter mode, and actual drag recognition, and of course the neutral idle control. These transmissions are air-cooled, so they have an oil-to-air cooler, and we're going to talk about that towards the end of the webinar, the different type of cooling systems used and the heat exchangers used for these. A little bit about the engine start-stop function. They have a system which is called the hydraulic impulse oil storage system, HIS. At idle, the engine automatically shuts off, so the HIS system supplies oil pressure needed to keep the clutch elements engaged while the engine is off. This way here, when you're ready to go back into drive, it only takes about 350 milliseconds after starting the engine that the vehicle is all ready to go in gear and travel on. Now this start-stop function, obviously it saves fuel consumption by about 5% and reduces the CO output for pollution. This is what the sport models will look like in the Chrysler and Charger, as well as some of the European models. You may have some shift paddles right here on the steering wheel. A lot of vehicles have gone this way, less distraction for the driver. If you want to manually shift, you can just upshift by clicking on one of the paddles on the right, or downshift by clicking or pushing on the paddle on the left. Here's the complete list that I found so far up to date as far as what models you will find this transmission in. And as you can see here, there's quite a few. ZF is competing with other manufacturers like Warner and Jatco to where they'll actually fit the transmission to whatever drivetrain manufacturer has. So you can see they're pretty widespread. Here's your component identification. You can see that we have our two brake clutches, A and B, right here at the front of the transmission. We have 3 planet gear sets here, and there's our 3 driving clutches, and also the last final planet toward the back of the transmission. Here's your clutch application chart. And you can see no matter what gear we're in, even in reverse, we only have 2 elements that are released for less drag. And you can see in first gear, second gear, all the way through, there's only 2 elements that are left open for less drag during all the gear changes. Now this is a power flow for first gear with the neutral idle control activated. This, like I said before, improves fuel economy for city driving. Now when this is activated, you can see here that we're slipping the B clutch, and that's a holding clutch. We'll allow 10% slip, and this way here will prevent the creeping and any extra load on the engine while we're sitting still. This will save fuel and load on the engine. We also have in text the different components that are being held, which is being applied. So you can see from here that what our driving elements are and what our driven elements are. Now this is first gear with the neutral idle control not activated. And you can see the holding elements and driving elements here. 100% slip on the converter. So now we have our normal drive moving forward. And that's what we're showing you right here. This is first gear driving. And we're at about 4.69 to 1 ratio on the output shaft. Second gear, we go to 3.13 to 1. You have all your applied elements and holding elements listed for you on each one of these. Now, one of the main reasons that I like to put these flow charts in a handout material is if we're dealing with a noise, and you know how tough that can be when you're working in a shop trying to find out what planet or what gear the noise is coming in. So using these flow charts and seeing what element is held and what is driven, we can basically have an easier way of trying to diagnose where that noise is coming from. So here we are in third gear. We're at 2.10 to 1. And this is fourth gear. Now in fourth gear, what's a little unique here is the P3 and P4 planet assemblies are all turning at a 1-to-1 ratio. We still have an underdriven ratio of 1.67 to 1 at the output shaft. So obviously if a noise changes in this gear, we know which planets are now being driven. This is fifth gear. We're still underdriven at 1.29 to 1. And now we're in sixth gear. And at this point, the entire drivetrain is turning at a speed of 1 to 1. So this is a direct drive at this point. So that gives us two overdriven ratios, seventh gear at 0.84 to 1. And eighth gear, which is 0.67 to 1. So we have two overdriven gears here. Here's your power flow in reverse, and you also have the output shaft ratio listed for you on this diagram. Okay, let's talk a little bit about the solenoid identification. All the solenoids are mounted to the TCM. Just like on the ZF6, they can be removed from the TCM. We have 5 shift solenoids. They're used to control all 5 clutches. So obviously we don't need a manual valve here. We have a solenoid to control each clutch. The TCC solenoid is used just for the torque converter clutch. And then we have a line pressure and park release solenoid also. Now the park release solenoid is an on-off solenoid. And if you have the E-shift type valve body, which we're going to cover here in the webinar, you have a park hold solenoid, which is mechanical. It receives no oil. Now all the variable force solenoids for each clutch are approximately 5.5 ohms. The on-off park release solenoid, which receives hydraulic pressure, and the mechanical hold solenoid that does not receive any oil are both around 25 ohms. The park release on-off solenoid is normally open. The variable force solenoids A, B, and TCC are normally vented. Obviously with the power off, we have no pressure being controlled at this point. The system is vented. Solenoids C, D, and E, as well as line pressure, are normally applied solenoids. When power is off, we have high pressure on those circuits. This is the solenoid identification. And you can see here this is an E-shift valve body. So we have a park release solenoid here. And we also have the mechanical hold solenoid here to the right. These orange circles that you see around the valve body, these are the only bolts that need to be removed to remove the valve body from the case. Now this is good information for the installer if you have him removing the valve body for you. He doesn't take all the bolts out and then would have all the small parts and everything else falling down into the oil pan. Now this is kind of a rule of thumb, and it can sometimes raise several arguments. We like to identify where we removed each solenoid from the valve body. So we'll mark the valve body and we'll also mark the solenoid from that location. Now I know that all these white connector solenoids are the same, and you should be able to just put them where you want to. But if you check the part numbers on these solenoids, if they are different, that means that the flow rate of that particular solenoid is going to be different than the one that looks just like it. So if they're all the same part number, you should have no problem moving them around. But you should always mark where they came out, just as a general rule, so that we put them back in the correct place. Now, if you were on the tech line and we're having a problem with a particular shift, we may actually, even if the part numbers are different, we may actually ask you to switch one with the other as long as it's the same type of solenoid, and just to see if it changes our shift problem. Obviously, if it doesn't, then we'd have to look more into the valve body or for a leak in that particular clutch. This is the on-off park release solenoid. You can see here it's normally open. It measures about 25 ohms of resistance. We have reducing pressure coming into the solenoid, and because the exhaust is open, we release all that pressure out through the exhaust, so we don't have any pressure going to the park release valve. We turn the solenoid on, block off the exhaust. Now we have full reducing pressure going right to the park release valve, and we're going to cover a little bit more of the hydraulics on that as we go further into the webinar. This is the mechanical park hold solenoid. Now, obviously, if we go into any type of fail-safe, and this thing is fail-safe to park, there's a manual release provided by either a mechanism, like in this particular vehicle we're talking about is a Audi, so they'll have a cover on the floor just in front of the driver's seat. That's so you can physically release it from park, because we're going to talk a little bit about different fail-safes later on. Now, when you do this, the vehicle must be running, and the shifter has to be in at least the neutral position. Now, if you have if you do release the park lock manually, on some vehicles there should be a warning light that will appear on the instrument cluster. Now, the locations of the different manual releases are going to be in different places on different vehicles. I know that the BMW with the ZF6 had the would default to park, and the only way to get it out, there was a little door with the key in a key lock on it that the ignition key would open, and there was a handle there to manually release it from park. So obviously on different vehicles you would want to look at the owner's manual to see where the manual release would be located. What we're showing you here is the park release or the park hold mechanical solenoid. This actually has 3 of these fingers on it. Now, when the solenoid is off, this brass piece will be spring forward, and we have no hydraulic pressure on the piston that's holding the shift rod in park. Now, the linkage spring will actually pull this piston to the right, and that engages the parking pole. Now, this is the normal position with the engine running in drive. You can see we've turned the solenoid on, and then also we'll have our park release solenoid activated, and that would allow line pressure to come in and push the piston to the left. Once this happens, we're going to pull the parking pole, the park rod out of park, and then the 3 legs that will be located on the solenoid will actually hold that piston in place. As you can see, the spring is pulling. We're contracting the spring because we're pulling back this brass piece that would release it. Now, one of the emergency functions they have here is if we're in drive and the vehicle is not moving, there's no vehicle speed signal, and you happen to open the door, as an emergency, the solenoid would be turned off, and as you can see, the pressure would be dropped out of the piston. The spring load on the linkage would pull the piston back towards the park and lock it back in park. And as you can see, the solenoid being turned off, the brass piece would come forward under spring tension and release the fingers around the piston. This is a little bit more on the park lock hydraulic operation. Here's our park hold solenoid. It's on. Obviously, we're in drive at this point. We have pressure now moving the piston to the left because we turned the park release solenoid on. So our reducing pressure comes in and now goes to the front of the park pole release valve, and that's going to help stroke the valve to the right. And once that happens, we have line pressure that's actually going to push that piston to the left. And then once the vehicle is driving, we're going to have pressure from the C clutch actually holding that valve back. There's another valve in here that I wanted to show you. It's called the position valve. And there's really only a couple of positions that this valve has. And this valve is to keep oil pressure to the C, D, and E clutches, or the C, D, and E clutch valves when the vehicle is operating forward, driving forward. This way here, if we have any electrical faults, we're not going to lose our forward clutches. As you can see here, we're in the park position. Line pressure is just sitting here at the valve. We're going to go ahead and put this in reverse or neutral position, and then oil from the park release solenoid is going to stroke this valve back. Now we have line pressure going through our C, D, and E clutches. So we already have pressure there for those 3 clutches. Now once the vehicle is in the forward position, oil is going to come back from the C or the E clutch, and it's going to hold this shuttle valve back. That's what's called the default position valve, and that's going to help keep everything stroked in the right direction so we keep oil to those forward clutches. Here are the variable solenoid functions, the A and B and the TCC variable force solenoids. Again, all the variable force solenoids measure about 5.5 ohms. These particular 3 solenoids are normally vented. So when there's no amperage or voltage going to the solenoid and it's off, our reducing pressure is just basically going to get vented out through the exhaust, and we don't have anything going through the control valves. Now you'll notice here when the solenoid is being controlled electronically, our reducing pressure can now go to the control valves, and you'll see that each one of the solenoids will have a damper valve. Now because this oil is being pulsed by the solenoid, they want a smoother, steadier hydraulic signal going to the control valves, so that's why the dampeners are installed in the valve body to take that pulsing out of the circuit. These are the line pressures, the C, D, and E clutch variable force solenoids. These are normally applied, same resistance, and obviously they work the opposite way of what we just showed you. When the solenoid is off, we're blocking the exhaust, so now we have reducing pressure going right to our damper and right to our control valves. We start to vary the voltage or the amperage to the solenoid, and then we can actually control how much we're venting and how much oil is being going to the control valves, and that's where the damper would come in and clean up that signal. Now in your handout, on the next slide you'll see a note that I added. I just wanted to let you know that if you wanted to go ahead and look at your screen when you see a slide like this, up in the upper right hand corner when we get to the next slide, you can go ahead and click on that little camera icon. It'll actually take a picture of the slide, the next slide coming up, and it'll put it right there on your desktop. Now you can do this right now, or you can wait till a few days after the webinar has been finished, and you can go to our website if you're a member of ATRA and just download the video, and that information will already be in the video. Also, if you're a non-member and you can't go to our website to download this, just go to Seal Aftermarket Products website if you're a non-member, and you can go ahead and download the video from there. Now this is the information that I was talking about. Someone had asked me in a previous webinar what failsafe was on this transmission, so I wanted to add that to the other webinars so that anybody else has that question, you'd have that information in here for you. Now as you can see, these are normally vented solenoids. The park release is normally open, and what we're showing you here is when it's unpressurized, when it's pressurized, and what clutch is applied at that time. So for each gear, we're showing you what solenoids are being pressurized or unpressurized. That means if obviously this is a non-venting solenoid, this is a normally venting solenoid, so if we turn it off, we're going to have no pressure there. So obviously this solenoid is being turned on at this point to provide pressure. So if you take all the solenoids and turn them off, looking at the way that they actually work, whether they're normally applied or normally vented, you can see that 6th gear in forward would be your fail-safe gear. So while you're in any forward gear and it goes to fail-safe, you'll go right to 6th gear. Now if you're in park, neutral, reverse, or when you're turning the engine off, if there's any fail-safe at that point, once you restart the engine, to default to park. So that's why it's good to know where the manual park release is going to be located on the vehicle you're working with. Obviously, if you start the vehicle up, you put it in gear and it goes right back to park as a default. You won't be able to roll the vehicle unless you mechanically release the park rod. Let's talk a little bit about the direct shift operation. This is what we were talking about earlier. Even though this is an 8-speed, during the downshifts, whether they're a coast downshift, and you can obviously be coasting lightly to a stop, or if you're having a heavy braking on the vehicle coming to a stop, or even kick down, there's going to be different strategies for the actual downshifts. As you can see, the first one here, we're talking about going from 8th gear to 6th, 4th, or even 2nd. So depending on how much we're braking or how much load is on the transmission and the engine at the point of kickdown, it's going to determine how this thing downshifts. Now the same thing can be possible for the upshifts. It's not uncommon to see any of these later model transmissions with several gears like 8 speeds and even 10 speeds or 7 speeds. They can actually skip a shift depending on actual throttle opening and load. This is the torque converter. It has a dual damper system very similar to the ZF6. And as you can see, the hub here is splined, and that's so that we can drive that chain to turn the pump. This is the TCC function for release. This is the hydraulics for this. And I just wanted to show you that if you're using a computer to look at the handout material, and you click back and forth from the applied circuit over to the release circuit, you'll see very easily what valves are being controlled by pressure through the solenoids, and to give you a better idea of how lockups work. And obviously, if I had any kind of a lockup issue, I want to go and check these valves, these valve lands for any type of wear. Any dampeners that are in the circuits that could cause a difference in how the pressure or the solenoid controls the pressure is another place we need to look. It's not uncommon to take this valve body apart and find that the little ball at the bottom of the dampener is flattened out. Now at this point, the dampener is going to be below the surface of the top of the edge of the valve body where it meets the plate, and we're going to have a leak in that area. Now we have the valve body out, it's on the bench, and we want to remove the TCM from the valve body. The bolts that you see identified here by the letter A or B, because there are two different lengths. These are the only bolts that we need to take off to remove the TCM. Going back on with the TCM, we want to torque those bolts to 8 Newton meters. You also have the torque specs for the valve body bolts to the case in your handout material also. Now, once we get the bolts out and we want to remove the Mechatronics or the TCM from the valve body, you're going to find these two alignment pins here that may drag in the valve body. So we don't want to just pry anywhere because this is all plastic. And over time and heat, this can become very brittle. So if we're going to pry this off the valve body, or if we have to pry this off, especially because of the solenoids here, you're going to want to pry right near these two alignment pins so we don't crack anything. Once the Mechatronics has been removed, you can see here this is the actual heat sink. This is to remove heat from the TCM or the Mechatronic. And as you can see, everything's hardwired right in. So we have our input and output speed sensors hardwired right to the Mechatronic. And also we have a temp sensor that's part of the Mechatronic itself. So any of this, like a temp sensor goes bad on this, you're going to have to replace the whole Mechatronic. Now the pin ID that we're showing here, these are the power, ground, any data stream coming from the Mechatronics, obviously to start the vehicle, and your reverse lights. So you're going to need to get the wire diagram for the vehicle you're working on to identify what pins are going to where, so that we know what we're working on whatever vehicle we have. And if we flip the Mechatronic over, you can see the back side of the Mechatronic assembly itself. Now the speed sensors, they are two speed sensors, the input speed and output speed. They're both Hall effect. And basically what the output speed is going to be looking at is the spark lugs on the P4 Planet. And the P2 Planet, once it's assembled inside the drivetrain, there's a row of magnets that the input speed sensor is going to be looking through this non-magnetic shell and see these magnets rotating past it to get a signal from that. Now ZF refers to these as intelligent sensors. And here's a little bit better picture. As you can see, the input speed would be lined up here. This would be bolted in place, and that pin would line up right along the spark lugs. This is a little bit information here about the pump itself. We already talked about it being chain driven. It's a double stroke vane type pump. And as you can see, the splines on the converter hub would actually contact these splines here, turning the chain and driving the pump. Here's another look at it in a cutaway from the transmission. Now on the pump function itself, as you can see, this is a dual type pump. It's got two inlets from the sump into the pump. Vane type, and we have also two outputs coming out of the pump. Now this is an extremely small pump, but it'll produce a high amount of volume and pressure in a real quick time by its design. And it also helps reduce any kind of cavitation or noise because they're using this dual inlet and dual outlet setup. And also in this diagram you can see exactly how the pressure regulator system works on this ZF8. We mentioned earlier about the different types of cooling systems or heat exchangers that they use on these vehicles. I'm just showing you this Audi, which is called an Innovative Thermal Management, or ITM. There'll be different names and different types of setups for other vehicles like BMW and Land Rover and those type of vehicles. What can get pretty confusing with these is they are actually computer controlled on some of the European vehicles. And in this one, what we're showing you is in the cold state, the actual heated water from the engine is going through the heat exchange, which is located here in front of the transmission. And this is being monitored by a temp sensor. Now, once the temperature gets to operating temperature, the computer will control this valve, which now cuts off the heated oil, or heated water rather, from the engine going through the heat exchanger, and now just has cooling water going through to help cool the transmission. So they're trying to maintain the transmission at a normal operating temperature because transmission does work best at operating temperature. So they're going to heat the fluid up quickly to get it up to operating temperature faster, and then once it's there, the computers will control that temperature at that point. Now on the Dodge vehicles, as you see here, this is the 8HP45, they call theirs a Thermal Management Unit, or TMU. It's just another heat exchanger. Instead of computerizing it, they just use a thermal control element to control whether the water going through the fluid warmer, or exchanger as we call it, whether they're going to have the warm water from the engine going through it or cooling water going through it to cool the transmission. Here's a couple looks at hybrid models. They can come in just about any vehicle that has hybrid. We're showing you the Dodge here at the top. You see it have an electric motor here with pretty big terminals for these orange cables that you see here. And they still have a torque converter, a hydraulic torque converter. You want to be careful when you're putting one of these on the lift that these orange cables run close to the frame. We don't want to pinch these or damage them in any way. It could be quite dangerous. Dodge uses the same type of system as Mercedes for their hybrids, called the Dynastart system, which is very similar to Mercedes. Now, if we have a stop-start function, we're going to have what they call a wet starting clutch. This is the type of converter they use with the start-stop feature. And like I said before, with the HIS system, It only takes about 350 milliseconds for the transmission to be in gear once the engine restarts. There's a closer look at the HIS system. Now, when the engine is running, they're basically going to force fluid down into this HIS accumulator piston. And it's going to stroke it back against the spring till it reaches this latching solenoid, which basically locks onto it, very similar to what we saw earlier for the park hold release. So it works the same way as far as that goes. Now, when it comes to a stop, the solenoid is going to release the piston, and that oil is going to be forced into the clutch assembly so that when the engine starts up again, it's ready to go, and there should be no delays in drive when you go to take back off. All right, I want to thank a couple of other sponsors that brought this in part by to you guys for the webinar to see it for free. Ray Bestis is one of our co-sponsors, and I want to show you a short video of their product.
And at Ray Bestis, performance, quality, and reliability are a part of every product.
I'm Transmission in Tampa, Florida. I've been rebuilding transmissions since 1975. We have been using the Ray Bestis GPXs and GPZ clutch plates. We use the GPXs in all of our Honda rebuilds. We build a lot of diesel high-performance transmissions, and we use the GPZ clutch plates in this application. We also use them on our everyday heavy-duty, hard-working work trucks with great success. I believe these GPZs are the best clutch plates I've ever used. They give us the durability and the performance that we're looking for.
And at Ray Bestis, performance, quality, and reliability are a part of every product.
Okay, I would like to also thank WIT as a co-sponsor to make these webinars available to everyone, and to Seal Aftermarket for sponsoring all our webinars to make them free for everyone to view.